Starting lesson 1.8. We'll be in it for a little while, but I want us to kind of take it in pieces so that we are going to hopefully, this is a really important lesson. We use ratios and rates and proportions, all of those things. We use them a lot in our everyday lives. So we have to make sure we have a good understanding of them. So today we're going to talk about ratios and rates, as the title says. So the ratio of A to B, remember, what is a ratio again? Did anybody know the definition for a ratio? We talked about that yesterday when we were doing the hearts and the squares and the stars. What's a ratio? What are we doing in a ratio? Open your books if you have to. Figure it out. What are we doing in a ratio? What is a ratio? Why is there such a thing? Yeah, we're comparing one thing to another. So yesterday, when we were going through that homework that you had done, we were comparing the number of stars to the number of hearts. We were seeing what relationship they had to each other. We talked about the number of boys to the number of girls in this classroom yesterday. What did we decide? That the ratio of boys to girls is greater than 1, or was it less than 1? Are there more boys than there are girls? Okay, if there's more boys than there are girls, the ratio has to be greater than 1. It has to be greater than 1. In fact, I think we decided that for every 2 boys, there is 1 girl. Okay, so we have a ratio of, actually, if we divided that out, that would be 2. So when we compare, what we have is a ratio. And typically, we will see it written as a fraction. So if we have ratio of A to B, we are comparing A to B, and A comes first in the comparison, so it has to be upstairs in our fraction. B comes second in the comparison, so it has to be downstairs in our fraction. Another way we might see that written is like this: A colon B. In some of the other countries, they actually treat the colon like we do the division symbol, like we do the fraction bar. So that means division to them, that means fraction bar to them. That's another way that we can actually write it. So let's set up a ratio relationship here. We have our football team won 8 out of 15 games. What was the team's ratio of wins to losses? Wins to losses. So let's circle that right here. That's really important that order matters in our comparison. They want us to compare the wins to the losses, not the losses to the wins. They want us to compare it in that order. And it says that they won 8 out of 15 games. So do we have all the information we need right now? If we're going to compare wins to losses, how many wins were there? 8. How many losses were there? 7. What do you have to do to get that?
You gotta subtract the 15 and 8.
Yeah, you got to take the 8 away from the 15 because they played 15 games altogether. So this one they didn't just, hand us the number of losses. They had to make us work a little bit to get it. So the number of losses is actually 7. So when we set up our comparison, our ratio of wins to losses, what's going to go upstairs? What's going upstairs in our ratio? Okay, and how many is that? 8. They won 8, and they lost 7. So the win to loss ratio is, can that be simplified? Can 8/7 be simplified? No, so we would just say the win to loss ratio is 8/7. So now just by looking at that 8/7, tell me something. Just by looking at the ratio that we got, does our ratio seem to make sense? Did they win more games or did they lose more games? They won more. So our ratio then should be what? Greater than 1 or less than 1? It better be greater than 1. Is 8/7 greater than 1?
Yes.
Yes. So it seems to make sense that we have a good ratio here. So we always want to not just write something down, but we want to say, does this even seem reasonable? Does it make sense? Okay. Sometimes I say ratios can be simplified. So let's look at this one here where it says the basketball team lost 12 games, They lost 12 games and won 16 games. So they've lost 12, won 16, They want us to write a ratio of wins to losses. They want to compare it in the same order again. So go ahead, would you set up the ratio that you think works for this one? By the way, let's use labels in our first setup, okay? So, okay, somebody give me the ratio that they've set up on their paper. What did you put down? Share with me. 16 wins over 12 losses. Okay. Let's start it out like that. Let's put those labels in the beginning to make sure that we can look back and say, did I do it in the order I was supposed to do it in? So wins is first, it needs to be upstairs. Losses is second in our comparison, it needs to be downstairs. So for every 16 wins, there were 12 losses. Can that be simplified into different terms? Okay, what could it be simplified to?
8 over 6.
8 over 6. Okay, so what did you do, Preston, to get 8 over 6?
I just divide the 16 and the 12 by 2.
Okay, so you divided the upstairs by 2 and you divide the downstairs by 2. And now it says it's going to become, so that becomes 8 wins, did you say?
Yeah.
Over 6 losses? Right? Okay, so there's another way to compare it. For every 8 wins, they lost 6 games. Well, Daisy?
I divided both sides by 4.
Okay, so in other words, this can be divided by 2 again, can it? Or in the beginning, you could have divided it by 4. So now, since I have already done Preston's, I've divided by 2. I say, you know what, I got 2 even numbers. I can divide by 2 again. So we get 4 over 3. So our ratio is 4/3. Does our answer make sense? Why? Why is 4/3 reasonable?
So it's been simplified.
It's been simplified. Okay, well, we can pat ourselves on the back that we know how to simplify a fraction.
Because for every 4 wins, there was 3 losses.
Okay, so for every 4 wins, there was 3 losses. So why is that reasonable? Why is that reasonable? Like, you know, for every 4 wins, there's 3 losses, or 4/3. Remember what we're going to think? Should it be greater than 1 or should it be less than 1? It should be greater than 1. Why? Because, well, we ended up with 4 over 3, which is greater than 1, right? 4 over 3 is greater than 1. Is that okay that it's greater than 1? Why is it okay? Seth, why is it okay that we ended up with something greater than 1? Just because it is, huh? Just is. Talia, why is it okay? Why is it okay that we ended up with something greater than 1? Sam, what? Because you're past a whole number. Okay, so why should it be, you know, like past a whole number? Why should it be past the whole number 1? Why? What do we know about this situation? If we're comparing wins to losses, and we end up with something greater than 1, what does that tell us? That they did what? Okay, let's go back to the boys to girls in this classroom. You told me there are more boys, right, than there are girls. And our ratio ended up greater than 1. So if we end up with something greater than 1, and we're comparing boys to girls, that says there's more boys than there are girls. What does this tell us? We ended up with something greater than 1. What should that say to us? There's more wins than losses. Did they have more wins than they had losses?
Yes.
Yes. That's why it's reasonable. That's why it's reasonable. Okay, so we're going to say, okay, reasonable answer. I'm going to circle and say I'm going to go with it. Okay, so we are right here. We kind of already said this. For every 4 wins, in simplest terms, every time they won 4, they lost 3. So if they played some more games, they might expect the same kind of results. Okay, let's just do some setting up of ratios and some simplification. Okay? 9 to 72. What would go upstairs? We're gonna compare 9 to 72. What goes upstairs? The 9 does. So we put 9 over 72. There's our ratio set up as a fraction. Can that be simplified? No?
Yeah.
Okay. So when it can be simplified, that means you can divide the same thing into something upstairs that you can downstairs. So is there anything that can be divided into 9 that it could also be by 3? Okay, so if we divide 9 by 3, then we have to divide the 72 by 3. You can use your calculators, I'll let you have them out. Hopefully you don't need for the 9 divided by 3 though. What's 9 divided by 3? 3. And 72 divided by 3 is? 24. Okay. How are you feeling? Are you convinced we can't do more? Is that our simplified ratio? What can we do? Oh, so now we can take that 3/24 and we can rename it again. We can divide by 3 again, you're saying? And 3 divided by 3 is? 1. Anything divided by itself is 1. 24 divided by 3 is? 8. Okay, now are you convinced that we can't do any more? The only thing that would be, they would both be divisible by now is what? 1, and that's not going to get us anywhere. We would be spinning our wheels. So we're going to say our final answer for this one is 1 to 8, 1/8. So 9 of something compared to 72 of something is the same as 9 of something compared to 72 of something is the same as 1 of something compared to 8 of something. They really are the same thing. We can break it into smaller terms. Okay, you go ahead and simplify 36 over 60. Show your work. I'm going to let you use your calculators, but you're going to show your work how you got there, the process you used. Some of us might have to do more divisions because we don't see the largest number that can be divided out, like when Maisie said we could have divided 4 that time. We did it in 2 steps, by 2 twice. Maisie, you done? But for your paper, I'm going to show yours on the, or if you don't need your paper, you don't have to, but show yours on the board here for us. Sure. Now you just keep doing what you're doing. Don't be copying from Maisie. She gets to do it her own way, and you get to do it your own way. Thanks, Maisie. But hopefully in the end, no matter which, road we took, we all end up with the same simplified ratio. So you need to finish yours so that you can see if you need to challenge Maisie or not. Anybody want to challenge this? Or did you all get 3/5? You got 3/5? Everybody do the same way Maisie did? Everybody start with dividing by 12? No. We might not have started with dividing by 12. Let me hear some of the others when you started dividing by. So you started with 6. Anybody with Blake? He started dividing by 6. He says they're both multiples of 6, okay? And then after you divided by 6, what was your other? Then you had to divide by 2, didn't you? Okay? Anybody do it another way yet? Because there's still another way. Preston.
Divided by 2 to start off, and then divide by 2 again.
Okay, so you divided by 2 to start off with, and then you divided it by 2 again, and then what did you have after that?
After the first one, I got 12 20th, then I got 6 10, and then I did it again.
I think you divided by 3 the first time, not 2. You got 12 20ths. Right?
I got
Okay, just
18.
say that as like
Oh,
you
yeah.
should have posted. So
Divided.
you divided by 3 first, and then you divided by 2, and then you divided by 2 again. Okay. Adam, what'd you do?
I got the same thing.
Did you do it the same way, 3
Well, I
first?
just now I changed it.
Changed it up. Okay, so anybody divide by 2 first?
Yeah, I did.
Yeah.
But then I changed it.
Why change it? Can we divide by 2 first?
Yeah.
Okay, and then after you divide by 2, you would have 18 over 30, and then you say to yourself, maybe you would say, oh, those are still even numbers, so I can divide by 2 again. So then you divide 18 by 2 and you get 9, and you divide 30 by 2 and you get 15. And then you'd have 9 15ths, and then you better not stop because 9 and 15 are both divisible by 3. So we can't stop. And some of us are going to take a longer path there, but that's okay, or a different path there, but that's okay. We just want to get it down to the simplest terms. So 36 of something compared to 60 of something, hear me? 36 of something compared to 60 of something is the same as 3 something compared to 5 of something. Yeah. Okay. So, anybody have any questions on being able to simplify ratios, set up ratios, work with them so far? Okay, let's go to the back side and see what's happening back there then. Okay, now we're talking about rates. I want you to put a box around that word rate. I don't want us to not see how important it is, because we work with rates almost every day, probably. A rate. If A and B, in other words, our ratio, our upstairs A and our downstairs B, if A and B are measured in different units, if A and B are measured in different units, then A over B is called a rate. So, can anybody give me an example of a comparison of 2 things with different units that we could call a rate maybe? Anybody here have a job?
I have.
You do. Okay. Preston, would you share with us, how do you get, you don't have to tell us how much, how do you get paid? Do they just like, at the end of a shift, hand you a $20 bill, or what do they do?
Sometimes I get tips, but usually like every other Thursday I get like a paycheck.
You get a paycheck every other Thursday, okay? How do they decide how much money to give you on that paycheck?
On like how much hours you work.
Okay.
And
So you make so many dollars per hour.
like 8 hours and $8 an hour.
Okay, so when you get paid by the hour, you're comparing how many dollars you get to how many hours you work, right? They compare how many dollars you're gonna get for how many hours that you work. Okay, give me another comparison of something in different units that happens in our everyday lives.
How many groceries you get, how much money you spend?
Okay, so what about groceries?
Like how many groceries you can get for how much money you have?
Okay, so how many items you can get for so many dollars? Okay, so items per how many dollars? You're comparing that way. Anybody notice on the shelf tags at the grocery store that it also tells you how much you pay for every, like maybe ounce? So how many dollars per how many ounces? They help you out and say, you know, here's how much you're gonna pay for that. Anybody in here drive? No? Okay. What happens when you drive? Is there anything that's important to you other than, you know, you better have your driver's license, it better be current. Gas, what about gas? Yeah, you need it to be able to drive the car, right? So when you go to buy gas, how do they decide how much to charge you? Yeah, it's so much per gallon, right? So we have how many dollars it's going to cost you per gallon. So we're comparing dollars to gallons. Do you care how many miles you get on your car per gallon? I do. I care how many miles I'm getting per gallon. There's lots of different rates in our lives. Well, when we take those rates and we oftentimes write them as a unit rate. Would you box that also? Typically, when we talk about rates, we don't talk about it as something like this. Preston gets $40 for 5 hours of work. That isn't typically how Preston would walk around telling people, you know, you should get a job at, where's the Burger King? You should get a job at Burger King because you're going to get $40 for every 5 hours of work. Is that typically how you would say it? How would you typically say it? $8 for every 1 hour that I work. Yeah, $8 per hour. So when we talk about rates, we typically talk about them as unit rates per one given unit. We don't say $40 for 5 hours of work. We say $8 for 1 hour of work. Okay, so that was probably a good example that we could use right there. We could talk about it being as dollars per hour. What's another one we talked about? We said miles or dollars per gallon, right? We talked about that. Again, we don't say, oh, you know what? Out at Casey's, they're charging $12.50 for 4 gallons of gas. That isn't how we talk about it. We talk about how much is it for every gallon. So those are like examples of unit rates. Okay, so let's find some unit rates. We have a plane that flies 1,200 miles in 4 hours. Whenever you're setting up these ratios, first of all, you got to make sure you set them up so they're going to make sense. Do we talk about miles per hour, or do we usually give our information in hours per mile? Miles per hour. So that's the first thought we have to have. How should I set up my ratio? How should I set up my ratio so it'll make sense? It makes more sense to say miles per hour. So the first thing we do is make that decision so that we can set our ratio up in that order. 1,200 miles over 4 hours. Okay, now we have a fraction to simplify here. What do you think? They're both even numbers. I suppose we could start with 2, right? Should we try 4? Do you think 4 goes into 1,200? Yeah, because 12 is a multiple of 4, isn't it? 4, 8, 12. So let's divide by 4. Because we want a 1 downstairs, so that's kind of like, we're hoping that it's divisible by 4 then. Actually, we're just going to make it happen because we want a 1 down there. So 4 divided by 4 is 1, right? And that's 1 what? What's its label?
Hours.
Hours. And then what is 1,200? 1,200 divided by 4?
300.
300. Okay. So 300. And what are those? Those are miles. So how would we typically see that written? Probably rather than, we don't have to keep it over 1. How would we actually typically see that written? Here's how we.
Miles.
Yep. Go ahead, Adam.
Oh, sorry, someone else.
No. 300.
It'd be just 300 miles.
Well, no.
300 miles per hour.
Per hour, there you go. We got to finish what's downstairs. MPH, isn't that typically how we would see miles per hour written? So this plane is traveling at a rate of 300 miles per hour. Okay. So, sorry to make that confusing. Here's what we're going to do. We're going to divide both the top and the bottom by whatever the number is downstairs, because we need a 1 downstairs, okay? So we're always just going to divide by that. So, let's go on to our mowing 3 lawns and earning $45. Would it make more sense to figure out how many lawns you do per dollar, per $1, or would it make more sense to figure out how many dollars you get paid for 1 lawn? Which one makes more sense?
Dollars per lawn.
Dollars per lawn makes more sense than lawns per $1, right? Do you think you can even do even get paid a whole dollar even for, or even be able to do a whole lawn for just $1? I kind of doubt it. So let's go with this one. So that means we're going to put the $45 upstairs in our ratio and the 3 lawns downstairs, and we're going to use labels in our ratios, just like this. Don't leave them out. It won't count as having met the standard. Well, we got a 3 downstairs and we want it to become a 1, so we have to divide by 3. If we divide the downstairs by 3, we have to divide the upstairs by 3. So we do have our 1 lawn downstairs now. 45 divided by 3, 15, and that's 15 what? Dollars. Okay? So we end up with $15 upstairs, one lawn downstairs. There really isn't like a special abbreviation for this. We're gonna put it as $15 per lawn. So in other words, you get paid $15 per lawn. Blake, do you get paid more than that? I hope so, yeah, that's gonna, $35 per lawn? So, whew. Do you need any helpers?
No, it's okay.
Okay, so anybody have any questions? Because I want you to try the next one on your own. Remember, the first thing you gotta decide is what's the best way to set it up? Do I want it to be cards per dollar or dollars per card? Make that decision first and write that down. Do I want cards per dollar or dollars per card? Let's share our thoughts on that before we get too far into this problem, okay? What do you think? Do you think it would make more sense to figure this out as cards per dollar? How many cards can you get for every dollar? Or does it make more sense to figure out how much it costs you in dollars for a baseball card? Which way do you think makes better sense? What, Evan? We want to figure out how much is every card going to cost us, right? Wouldn't that be we would want dollars per card. So that helps us set up our ratio in the correct order. Dollars per card. Use labels in your ratio.
So you're expecting tomorrow's homework, right?
I am expecting this on tomorrow's homework, not just numbers on your paper. You're gonna put the labels with them. Or I can make your homework a whole lot more problems than it is. Samuel, are you done? Are you willing to come up and show yours up here? Okay, bring your paper up and you're gonna just write with your finger and it'll write it in green. Do you have an aversion to green at all? Are you okay with it? Do it with your finger though, not the pen. Oh.
Yeah. Two. Yeah.
Okay, just a second, get the pen. There you go. There you go. But do we want to be done with this one yet? Remember, it's supposed to be per one. What are you going to do next? How about you just add that on? What do you think we should do next? I got two, you have to divide those. Top and bottom by two. So what's $5 divided by two? You know? $2.50. Yeah. Thank you. Okay, so according to Sam, I'm gonna write it right down here. He says that it is $2.50 per card. Is that what you got? Now, Sam took a little bit different route maybe than you did. What did Sam? He started by dividing by 2, or 3. I mean, yeah. Excuse me. Thank you, Preston, for catching that. He divided by 3. But if we want it to be per one card, we can't stop after dividing by 3 then because that became a 2 downstairs. So then he had to divide by 2 next. So Sam, you want to get this added onto your paper? So he had to divide by 2 next. So then it would be 1 card downstairs. And I'm going to guess some of you just went straight to dividing by 6. Is that what some of you did? Hands up if you divided by 6 instead. Because there's a 6 downstairs, so what we can do is we can say, you know what? I can just go straight to dividing by 6 because I want a 1 down there. So 6 divided by 6 is 1. Then I gotta divide by 6 upstairs. And does 6 go into 15 evenly or nicely or get a whole number? No, 15 is not a multiple of 6, so it doesn't go in there for a whole number answer. You get the 2.5, and those are dollars, and you get the 1 card, but we don't say that money is 2.5, do we? How do we say money? $2.50, so we have to stick that 0 on there so that it looks like the coin, the change part that we need, okay? So $2.50 per card is what we should end up with. Anybody have any questions? You will not get your paper stamped tomorrow without all of these labels going on in your work, okay? There was only one place on our notes. Let's go back to here. Look at, we were doing labels here. Where didn't we do them? Right here, when we didn't know what the 9 and the 72 and the 36 and the 60 were representing. We didn't use labels there because we didn't know what those numbers were representing. But when we know what the numbers are representing, we use the labels, okay? Anybody have any concerns about that? Okay, then you know what the expectations are, and we're gonna hold you to it.